All right, boys and girls, this is the very first podcast that I'm doing of one of my lessons. So, don't you feel special? All right, so this was our warm-up for the day. This is just a review. We did this last week. How do we solve this? Well, we look at the zero product property. We know that either this clump of stuff has to equal 0 or this clump of stuff has to equal 0. You should remember that well enough that to know that the solution would be either -9 or -8. So I can write that as x equals -9 or -8, or I could write that as the solution set of -9 or 8. And I should also check my solutions. I should plug in -9 into my equation here to get this. Does that equal 0? Sure enough, 0 times -1 does equal 0, so my first solution checks out. I'm going to plug that in also -8, check -8 to see if that works, and sure enough, 1 times 0 equals 0, so both of those solutions work. So now what I'm looking at is this quadratic expression, or trinomial. I can't solve this yet, but what I can do is I can factor it. And if I factor it, it's going to look a lot like that, and then I'll be able to get my solution. So, if I factor it, I should be able to do that in my head pretty easily right now, because this has just x squared. We're going to learn today what to do when there's a number other than 1 here. But in any case, I have x plus 4 times x plus 9, and so my solution should be -4 or -9, because if I plug those in, then I will get 0 for one of my factors, which will make the whole solution 0, because if this is 0, then that'll equal 0, and if this is 0, then that'll equal 0. But now what I want to do with my solution set is I don't actually want to plug it in here, because I might have made a mistake there. I want to plug it into my original equation. So if I plug in -4, I get -4 squared plus 13 times -4 plus 36. Maybe that equals 0. I've got 16 plus, sorry, minus 52 plus 36 maybe equals 0. Well, I can see if I take my 16 and my 36, I'll end up with positive 52. Sure enough, positive 52 minus 52 does equal 0. Let's do the same thing with -9. -9 squared plus 13 times -9 plus 36 maybe equals 0. 81 minus 117 plus 36 maybe equals 0. I'm going to do the same trick I did before. I end up with 117 minus 117. Sure enough, that works, so that is my solution. All right, if you're not understanding this, use IXL, because this is fundamental to where we're going. All right, on to today's lesson. Factoring trinomials when a is greater than 1. What on earth am I talking about when I'm saying a is greater than 1? Well, here's the way we describe trinomials or quadratic expressions. We say a squared plus bx plus c. There we go. A squared plus bx plus c. That's how we refer to them. So we're going to factor 2x squared minus 11x plus 5. We learned last week that we could factor out a greatest common factor of 2, but we can't. These are going to be really ugly if we try to do that. So we're going to have to factor this whole expression. Well, we can think, because b is negative and c is positive, both factors of c must be negative. Ha ha! Okay, they have to be negative, because a negative times a negative is going to give us that positive, and we can add a negative and a negative to get a bigger negative. All right, so I'm just rewriting my expression up here because I ran out of room. By the way, the factors of c matter now. It used to be that I didn't care what would get us our sum and what would get us our product. It didn't matter what order they went into. They matter now because a is no longer the same. If we've got an a of 2, and you'll see it in a second, our two factors are going to have different coefficients of x. So what I'm going to look for is possible ways that we can get to a, possible factors of a. Well, what can we multiply to get 2? We can multiply 1 and 2. So I'm already going to look down here and I'm going to say, well, I must have an x at one part and a 2x for the other factor, because those are the only two factors, 1x and 2x. This part, it doesn't matter what order they come in. These constants matter, okay? So that's what I'm saying, the order of C matters. So what possible factors of C do we have? If we have 1x times 2x, what can go in here? Well, negative 1 times, what can be C, that 5? Well, negative 1 times negative 5, of course. And like I said, the order matters, so the other possible factors are negative 5 and negative 1. Well, if we write out these expressions, well, that means we could have x minus 1 times 2x minus 5. We know that this is going to give us 2x squared, right? X, our first terms, if we FOIL. And we know that this, for our last terms, is going to give us a positive 5. The question is, what do we need to do to get to b, that negative 11? So all I care about is the O and the I in FOIL. We know we've got F covered, we know we've got L covered. What about O plus I? Well, so O is going to be x times negative 5, which will give us negative 5x. The I in FOIL will give us negative 2x. And if we add those together, we'll have negative 7x. But we're looking for negative 11x, so that's not going to do it. Let's try again. Let's try with these numbers. We know our firsts, we don't care about. We know our L's, we don't care about. What we care about is our outside and our inside. So if we've got x times negative 1, we'll have negative 1x. And if we have negative 5 times 2x, we'll have negative 10x. And if we add those together, we'll have negative 11x. Yay, that's the magic number that we wanted. So this is our solution. We have x minus 5 times 2x minus 1. How are we going to know for sure? We're going to check with FOIL. So we're going to multiply our firsts, our outsides, our insides, and our lasts. We're going to simplify. And sure enough, we have our target expression. So we know that this is our factor of this. Let's look at another one. Factor 5n squared plus 2n minus 3. Because b is positive and c is negative, this time we know the factors of c have different signs. One is positive and one is negative. So if we multiply those, we'll get a negative. And if we add them, we could get a positive. But really what we care about is this. All right, so factors of a. Well, the only way we can get to this a of 5 is multiplying 1 and 5. So I can go ahead and write that out. I've got 1n plus or minus something times 5n plus or minus something. Question is now, what is that something to go in? So I could make a list of all the possible factors of c that can go in there. 1 and negative 3, negative 1 and 3, 3 and negative 1, or negative 3 and 1. Again, order matters now. So we're going to go ahead and start plugging them in and checking to see if we have our middle term, our C. Oh, sorry, our B. So we have n plus 1 times 5n minus 3. If we multiply our outside and our inside, we'll have negative 3n plus 5n. And that gives us 2n. Way, we lucked out. There's our 2n that we're looking for. Yeehaw, we're already there. So we know our solution is, we know that our factors are n plus 1 times 5n minus 3. And again, we should check with FOIL. And we know that I have our correct answer. Go ahead and pause the video to try this one out. You paused, right? You did your own work. All right. So what I did is I first thought, what are my possible factors of A? I've got 3 and 1. Doesn't matter what order I put that in. And now I'm just going to think, what can go here and what can go here? That multiply to 2, that give me that product, and that add, after I include that, to 5. Well, it's going to be 1 and 2. It's going to be negative 1 and negative 2 because I need a positive 2. So negative 1 and negative 2, all I have to think about is what goes where. Well, if I put a negative 1 here and a negative 2 here, I'll have negative 1 times x, that's minus 1. Negative 2 times 3, that's negative 6. That's going to give me negative 7. That's not going to work. So how about negative 2 and negative 1? Negative 2 and negative 1. Because now if I multiply it out, I've got 3x times negative 1 gives me negative 3. Negative 2 times x gives me negative 2x. Together, that gives me negative 5x. So I can check it with FOIL. All right. Now, what happens if my a is negative? Well, again, I'm still going to check for a greatest common factor. I don't have that, but I do have this negative out here that I want to deal with. So what am I going to do? I'm going to factor negative 1 from each term. And then that's going to give me negative times 4x squared minus 4x minus 3. And now I'm going to factor that trinomial. So let's get to it. We're going to factor this trinomial, but let's see if we can do it without this whole ugly chart, without that garbage. So I'm going to think it through. Well, what are my factors of a? 1 and 4 or 2 and 2. So I'm going to write those out. 1x times plus or minus something times 4x plus or minus something. Or 2x plus or minus something times 2x plus or minus something. And then I'm going to think about all the possible factors I could have of that negative 3. I'm going to list those out. 1, negative 3, negative 1, 3, negative 3, 1, 3, negative 1. Because remember, order matters. And I'm just going to start plugging them in. I'll plug 1 in here and negative 3 over here. And I'm going to think it through and say, all right, so 1 times negative 3 gives me negative 3x plus 1 times 4x. No, that's not going to give me negative 4. I know that's not it. So let's plug in negative 1, 3. Negative 1, 3, I get 3x minus 4x. 3 is going to give me negative 1x. Nope, that's not it. How about negative 3, 1? Okay, and some of you can already see the pattern here, and you already know, but that's okay. 1 times 1x is going to give me 1x. Negative 3 times 4, oh, that's going to give me negative 12. There's no way that 1x minus 12x is going to give me negative 4x, so it can't be that. Same thing with this 3, negative 1. It can't be that, so it's none of those. It's got to be one of these. All right, once again, my factors are the same. So I'm going to start plugging them in. 1 and negative 3, so 2x plus 1 times 2x minus 3. So my outside terms are going to give me negative 6. My inside terms are going to give me positive 2. Negative 6 plus positive 2 is going to give me negative 4. So that is my solution. Don't forget, when I write it down, I've got to plug that, I've got to include that negative that I factored out originally. I have to include that in my answer. And I could test it out. So don't forget to look for your greatest common factor. Here I've got this trinomial. And what is the greatest common factor that I could pull out of all three terms? Some of you are already saying 3, I know that. Something slightly bigger. What about this little booger right there? Sure enough, we could pull out 3x. And then we'll end up with times 5x squared minus 9x minus 2. And now we just need to factor this trinomial. You can pause and do the work on your own. Come back to see if you got it right. Here's my thinking. I know the only factors of 5 and 1. So I just need to worry about what factors do I have of c. That's the only positive. Well, actually, though there are more, but I didn't think about them. Because really, it could be reversed. My 1 could be negative and my 2 could be positive. But I lucked out. This worked for me. So that's my answer. All right, here's the homework. 3x squared plus 16x minus 35 equals 0. What am I going to do? I'm going to factor these out first. 3x plus or minus something times x plus or minus something. So I've got to think about those somethings that could be factors of negative 35. Ooh, it's a long list. And I'm just going to guess and check. 1 and negative 35, that doesn't do it. Negative 1 and 35, that doesn't do it. And let's face it, none of these 35s are going to do it for me. So I'm just going to cross off the rest of that side. How about 5 and negative 7? Let's see, 3x times negative 7 gives me negative 21 plus 5x. Ooh, that gives me negative 16x. You know what? I'll bet I just need to reverse the signs. So we'll try that. Negative 5 plus 7. So 3x plus 7 gives me 21x. Negative 5 times x gives me negative 5x. Positive 21 minus 5 gives me 16. Yay, that's my winner. So there is my factored equation. And now all I need to do is think about the zero product property. So either this factor has to be equal to 0 or this factor has to be equal to 0. So I'm going to set each factor equal to 0, solve for x. I don't need to show you that. And I'll end up with a solution set of 5/3 and negative 7. Okay, don't be too critical. This was my very first podcast, no, my very first video for you. There you go. So don't you feel special now?